Right, today we're going to be talking about how we make the print drops for the printer. So the printers that we're working with, they're CIJ, they're continuous inkjet printers. That means that we have a reservoir of ink, we have a pump, it takes the ink out, pumps it into a print head, where it comes out of the print head. Some of it comes onto the product we're printing, and some of it is recirculated back round the gutter into the ink reservoir. So the ink carries on being the ones we don't print, goes back around. But what we're going to look at today is this portion of the system. So how do we make the print drops in the head? So there's a lot of strange terminology that we use here. So in our print head, we have what we call the gun body. I'll just draw them, I won't draw them the real shape, we'll just draw them square and rectangular and so on. The gun body can have many different shapes and different sizes, but they call it the gun body because it fires the ink out of it as you would with a bullet. So out of the gun body will come the ink. The ink comes through, underneath here is a nozzle. And the ink comes out this nozzle. At the bottom there is a gutter. And there's also a hole in the plate where the drops can be sent out onto the product that's going to be printed. So there is print on the product. Also in here we have what we call the charge controller. And we have two deflection plates. So, we have the ink coming in, we have a valve that lets the ink go out, or stays in there, and we have another thing which we will call the drive rod. They have various shapes to these. The drive rod is the item that's going to vibrate the ink inside here at a particular rate. So this is very much like you going out into the garden, you've got a hose pipe in your hand and you are spraying water out of it and you start shaking the hose pipe and it breaks up into blobs. That's what we're trying to do here, because we need to get the blobs out so that we can put the different blobs onto the substrate. So we've got the vibration going on here, the ink is in this reservoir. There's also a heater attached to the reservoir to keep it at the right temperature. The reservoir inside the gun body, there is a valve over here, the valve opens, it forces the ink out of the head. Going through the charge controller where it's charged down here. Now, we're going to now look at this section of it. So we'll have a bigger section here. So we come out of the nozzle and the ink is starting to break up into its blobs. And eventually the ink will start to break up. Normally it has a dimple in the top when it's broken off. That is the important item here. That's called the break-off point. Now, why is that important? That is important because this is the moment that we put the charge onto the ink. So at that moment, that ink drop should just be entering the charge controller. Not above it, not below it, not in it. It should be just entering. So we have the charge controller. got a little tunnel where it goes into, and in here it will apply a charge, positive charge, onto that ink drop. That ink drop will carry on through, and over here we have a charge detection. The charge detector will check that that ink drop has a charge on it. The ink will carry on through, and the deflection plates will now have a influence on where this is going to go, because they will attract or repel this ink drop so that it falls into the right place, either the gutter or onto the substrate. Now, that's all good. That's the perfect way to have it. In the real world, things aren't like this. There's a lot of items that we can have that have an influence on this break-off point. So even though we might have set it correctly, things like the temperature of the ink, the frequency that we're vibrating at, the viscosity, how thin or how thick the ink is. That could mean that this break-off point happens over here. Now, instead of being able to get the full charge, it only gets a partial charge. Or worse still, we're applying a charge to this stream of ink that goes back up there. So if we want to apply 50 volts over here, it's not going to be 50 volts because it's all going to drain up into the top. So we have this charge detector here. And so every so often we send through a special sequence of voltages called the phasing volts. So I know if I put onto that, say for instance 60 volts, by the time I read it I should have round about 59 volts in that sort of region. If I don't get that, then I need to do some tuning of the ink to make the break-off point happen in a different part, and this is called phasing. You'll hear that term, phasing. So we might change what we're vibrating at, we might change the pump pressure, we might add some makeup for later because we're getting thick ink, we might do various things, but we will test again, we'll do one change, we'll test. If we're getting closer to the value that we should have, that's right, so we will test one where we're like pulling this ink stream up a bit and one where we pull the ink stream down a bit, and we'll see which one of those was better. So we had the first test that we did, we moved the ink stream a bit, we moved the ink stream in the other direction, which of those three gave us the best result? And then we moved to that result and we do the test again. As long as we've got time to do the test, we will carry it out. If we're printing, we stop the test, we go to print. When we stop printing, we come back and run the test again. So we're constantly tuning so that every print can have the best quality in it. So that's called the phasing. There's normally 16 phasing positions that it can have. And those are to do with changing the charge, the pressures, the vibration, and a lot of other things that go on in there. One thing you might ask is, how do you get a charge onto a liquid? So the inks that we have are special inks. They add salts into the ink, electrolytes that will attract in the voltages that we apply. So it's also very important that the ink that we use is not too old, because those electrolytes can fall out of the ink. So if I was to apply a voltage to very old ink, it's not really going to do much. So this is why our inks have things that are called shelf lives. It can only sit there on the shelf doing nothing for a certain time, and when it's in the system, the ink has a lifetime in the system. It's 2,000 hours, 600 hours, depends on the type of ink it is and how quickly the electrolytes would come out of it. So this is how we're going to make our ink drops. Any questions?
Was it? Can't remember. I probably heard, but what determines how far the drops are deflected? I mean, do you control the deflection voltage or the charge voltage on the fly?
So last week we had we did rasters last week, where we found out that rasters are made of drops. Each drop can have a voltage on it. So we can charge our drops. So the drops come out here and they're charged, and it'll be 90, say 180, 200. In this here there is two plates, and the two plates have electric field between them. So one will be positive in respect to the other one.
So that remains constant?
Yes, that's constant.
Okay, so
that one's constant,
yeah,
yes.
Okay.
So as this drops down, the 90 would be attracted or repelled, depending, over there. The 180 comes down and it goes over here, and the 200 might go over there. And that might give us the shape that we wanted. But of course, as we were saying earlier, if you didn't get the 90 on there, it wouldn't be put there. It might be put over there, overlapping a drop, and that's when we get
it makes sense. If you would be controlling the deflection voltage on to each drops, you would get very slow print speed.
Yes, yes. An innovation project for you. To see if you could do that. There are many ways, but this is kind of the standard way of doing it. Yeah.
So what impact would we notice if the system doesn't have enough time to phase?
So there you would get this bad print. So you would see, instead of having your print nice like this, because we weren't able to get the full, we applied the voltage, but because it was all joined, co-joined and went back up, we might in reality have something like 40 volts, 80 volts, and then maybe 180 volts got in somehow, and maybe 220 volts. So all the voltages go all over the place because of the stream. So instead of having it print like that, we might get it print something like this because of the voltage. And they're all attracting and repelling each other, but we get that. And that's bad phasing, so you'll see that as bad print. So bad phasing can of course be caused by the break off there, which can be in fact old ink. We're not with the right pressure on the ink, we're not vibrating it correctly. There's a whole host of problems that can cause that. When the printer's printing well, you can print very fast and it all looks good and it tries to print. Now some people, some printers rather, that's our label and that's our label, and they phase in this space here between labels. There are other printers where you phase, if possible, between the strokes. So you're on a constant phasing. So remember I said we normally do like 3 tests. One where I'll move it up, move it down. If you try to do it here, you might be able to do 1 test there and 2 tests there. So you're keeping this rolling set of results. Here, if they're too close together, you might do 1 and then might abandon it, or you might do all 3 tests in that area. So sometimes people, if you print a very long message, for instance, the printer might say to you, check the print quality, because it thinks it hasn't been able to phase in a particular time. To be honest, when the printer is up, the temperature of the ink and everything is running well, it's been running for a while, phasing doesn't really alter. So when you start up in the morning with cold ink, and then it heats up, becomes more viscous, then you get problems during the day. That's why it has to do a lot of work early on. Also, if your ink gets old as well, is another thing.
Can you tell if the printer is doing that adjustment?
On some printers you can, yes, because there is a screen where you can see the phasing where you are, and then you won't see it actually do the phasing, but you'll see where it's moved to. So you have a screen. You can have a screen, and in the screen is like a slider type thing, and it's like from 0 to 16. And you see it's normally sitting on say 0.7, and we go to test on one on this side 6, we'll test on 8, and then you'll see this move to 8 if 8 is better than for those circumstances. You're hardly ever at the extremes, you're mostly in the middle. If you do see it on the extremes, then there's a problem, because it can't really move here unless it wraps around to there, because there's nowhere else for it to go. So you check your pressures, your temperatures, and so on.
And you can find that information out in the printer status screen. There is information about phasing.
So when you're phasing, do you only put a small voltage on there because you're still going into the gutter?
That's a really good question to ask. Yes. So we've got the head. We've got drops that go onto the substrate, which will have a minimum and a maximum voltage on them. We have our gutter. We have drops that aren't used, are sent into the gutter. So the voltage that you're going to put onto the phasing has to also come in the gutter, but on the new printers, I think we put this on just on the inside, so you'd have to have your voltage just slightly more to go into the gutter. Some printers, where the ink stream is on the other side, they would have the voltage come this way, so it's just slight. So if that was, say, 60 volts to get into the gutter, these voltages are going to be around 58, 59, 57 maybe, something like that. Just picking some numbers there. So they would all end up in there. So the first printed drop might have a voltage of 80. So we've got quite a way to go. There's also distance between those two before we're actually going to get the drops here. Not a good idea to let drops on the edge of the gutter because we get build up, and then that flays because that can build up and start to affect that area.
And how do we remove the charges from the unprinted drop?
Right, when the gutter, you'll have there's normally an earth on the gutter to drain it away. Because after this bit is metal, after that you normally have a plastic pipe. It has to be flexible in the head. So they're all plastic pipes. So we have to drain it away in the head before it gets there. And the head, of course, is attached to the big conduit, and the conduit has an earthing in it to drain it away. And that earthing must also be attached to the printer chassis. So your printer chassis there, this is attached. So this and this is all at the same potential, and it can drain it away. Because you'll then end up, from the gutter you go back into your ink reservoir. You don't want that to be at higher voltage than anything else, because this is flammable ink. If there's a spark, we could have a fire. Yep, everyone happy with that? Right.
What we done?
Yep.
Thanks.